In section 9.3, we're going to continue our discussion about different isometries, in other words, different types of transformations. And if you recall, we've already discussed translating a figure and how to do that. Today we're going to look at reflections. And again, good news for you is that this should primarily be review from some first semester ideas. So the first thing we got to identify, well, first of all, a reflection is an isometry. In other words, when you reflect a shape, you don't change the shape. Okay, so the original figure and the new figure are both going to be congruent. All right, so the vertices of triangle ABC are 1, 2, 3, 0, 5, 3. Graph the reflection of ABC described. Okay, so the first thing we're going to do is graph the figure. So I have, let's see here, 1, 2. I have 3, 0. And I have 5, 3. 1, 2, 3. So here's A, B, and C. All right, so there's my triangle. Now, I got to reflect it in the x-axis. In other words, over the x-axis. These axes aren't marked, so we should probably mark them. So we have the x and the y-axis. Now, there's a few different things you can do. Okay, the first is know the coordinate rules, or we can just do it by counting. Okay, remember the coordinate rules for the x-axis, the x-coordinate stays the same and the y flips. Okay, so in other words, A prime here, x stays the same, y flips. Okay, for B prime, x stays the same, y flips. And for C prime, x stays the same, your y coordinate will flip, and then you just plot those 3 points and you're done. Or you can count. Okay, when I say count, that means I start at point A and I count how many units it takes me to get to the x-axis. I have to go down 1, 2. That tells me I got to keep going below the x-axis 2 more. And you'll notice A prime here is the point 1, comma, negative 2, which is exactly what we got up here anyway. Okay, I go to B. There's B. I don't have to go anywhere. So B and B prime are going to be the same exact point, which, again, same thing we had right here. And finally, C is going to be, I got to go down 1, 2, 3. So I got to keep going 1, 2, 3 more to get to C prime. And so now the red figure, the red dash figure, would be your reflection. Okay, I just take it, I flip it right over the x-axis. All right, I think I goofed up there. Oh, I goofed up the A prime. That's why I was going to say they don't look. They should. The triangle should look congruent. They don't look congruent to me, so I goofed up the A prime here. The A prime, I went down 2. I should have gone down 2. I went down 3 on accident. So, all right, you get the idea. So anyway, that's what the shape's going to look like. For B, same idea, except now we're going to reflect over the y-axis. Okay, so I'm still going to start with my same points. So 1, 2. 3, 0, and 5, 3. So here's A, B, and C. Now I got to go over the y-axis. Again, coordinate rules or counting. If I give you a graph, I think counting's easier. Okay, it doesn't really matter. So all I'm going to do is I'm going to start at A. I'm going to go left 1 because again we're going over the y-axis now. So I go left 1. I got to keep going left 1. There's A prime. Start at B. I got to go left 1, 2, 3. Keep going 1, 2, 3. There's B prime, and then go to C. Go left 1, 2, 3, 4, 5. Keep going 1, 2, 3, 4, 5. There's C prime. Okay. So now the black dotted figure would be the reflection over the y-axis. So again, should be something you're already familiar with. So hopefully I'm not reinventing the wheel here. Okay. It says the endpoints of JK are J is -1, comma, -2, and K is 1, comma, -2. Reflect the segment over the given line. Okay, so again, this comes back to the idea that you can either count, okay, or you can know the coordinate rule. Okay, the coordinate rule for reflecting over the line y equals x is very simply, you take your x and your y coordinate and you flip-flop them. Okay, so for y equals x, flip, flop, x and y, and then for the line y equals -x, you flip-flop, flip-flop, and opposite. So you flip-flop them, and then if it's negative, you make it positive. If it's positive, you make it negative. All right, so I'm going to show you both ways here. So first of all, the endpoints of JK are -1, -2. So -1, there's J, and then K is 1, -2. So there's K. And so here's my original segment. I got to reflect it over that line. Now, you got to be careful here. If you're going to use the counting method, you have to count diagonally. Okay, and here's what I mean by that. If I start at J, I go diagonally. I got to go half a unit diagonally, so I got to keep going a half a unit diagonally. That's J prime. I start at K. I got to go directly to my line, so I got to go diagonally. I got to go 1 1/2. I keep going. That's a half, 1 1/2. That's K prime. So now the dotted figure would be the reflection. Okay. Suppose you don't like the counting because you get confused when you're counting diagonally. No big deal. Okay. The rule here is flip-flop your X and your Y. So if J was -1, -2, that means that J prime is going to be -2, -1. Well, if you look at J prime right here, it's the point -2, -1. Okay. You look at K prime, again, all it says to do is flip-flop, -2, 1. K prime here ends up at -2, 1. So coordinate rules or just count. Okay, so we have the same point now. We have the same segment, I should say. So -1, -2. So there's J. K is 1, -2. And so that's our original. I'm a counting fan, but if you don't like that, don't worry about it. We'll use the coordinate rule here. So it says flip-flop, and opposite. Okay, so if I flip-flop J, I get -2, -1. And when I take the opposite, I end up at 2, 1. So I plot the point 2, 1. That guy right there is J prime. And then I got to do the same thing for K. Okay, when I flip-flop them, I end up at -2, 1. Take the opposite of both, I get 2, -1. All right, so 2, -1. There's K prime. And so now the dotted figure is our new reflection. Again, if I were going to count, I'd start at K, I'd go a half a unit, keep going a half a unit. Start at J, I got to go 1 1/2 units, go half, 1 1/2. All right, either way, you're going to end up in the same spot. So those are the 4 coordinate rules you need to know for reflections. Okay, over the x-axis, your x-coordinate stays the same. Over the y-axis, your y-coordinate stays the same, and you flip the x. And then obviously y equals x, you flip-flop. Y equals -x, flip-flop, and take the opposite of both. Okay, so I guess I'm going to summarize that right here. I probably shouldn't have I got a little bit ahead of myself. So if I take a point A, B, and I want to reflect over the x-axis, the x stays the same, the y changes. If I'm reflecting over the y-axis, the x changes, the y stays the same. Over the line y equals x, all you do is flip-flop your x and your y value, and then for y equals -x, you got to flip-flop and take the opposite. So those are the 4 rules you need to know as we move forward here working with reflections. Okay. Now, if you are a regular GL student, you can go ahead and turn off the video. You can work through these, but you're not going to have to use matrices to perform reflections. Okay. If you're in my honors class, you got to keep watching the video because we got to talk about matrices here. So what we've done is we've taken our triangle and we've put it into a matrix form. Okay. And now what we're going to do is we are going to just use this, and we can still use our coordinate rules. Okay, so in other words, we know if I'm reflecting over the y-axis, that means that all of my y-coordinates are going to stay the same. So I have 2, 3, and 1, and then all of these guys we're going to take the opposite of. So -1, -2, -4, and so now these, obviously, this would be my first point, my second point, my third point. Okay, I probably should have said D prime, E prime, and F prime. Plot those points and you're done. I'm not going to go through and worry about doing all that. Okay. Again, I would put this into matrix form first. So Q is -1, 4, R is 0, 1, and S is 2, 3. All right, we want to reflect over the x-axis. So the easiest way of doing this is to say, okay, all my x's stay the same and my y's change. However, we are going to look at multiplying here. So the reflection matrix for the y-axis, 1, 0, 0, -1. X stays the same, y flip-flop. So now when I do this multiplication here, row 1, column 1 is going to be 1 times -1, 0 times 4. So 1 and -1 makes -1 plus 0. That's just -1. Okay, and really, when it comes down to it, you know the top row is going to be the same, and the bottom row is just going to flip. Okay.
Miss Brooks, please dial 0. Miss Brooks, please dial 0.
So again, honor students, we will take the time in class to talk a little bit more about how to use these, the reflection, the x and y axis matrices, and how to multiply them and what have you. So as long as you guys know the coordinate rules coming into class tomorrow, you're going to be all right, and we'll go from there.